Hello and welcome to fifth topic, which is surds, and we are continuing with chapter Algebraic expressions. Now, a surd is a root that cannot be simplified further. So if n is an integer that is not a square number, then any multiple of square root of n is called a surd. So if it's not a square number, like so, this is a square number, so it's a root, and here we have square root of 8, which is a surd. We have 5 root 2, which is also a surd, and we can have square root of 11, which is also a surd. And those surds cannot be written as a over b, meaning that they are irrational. In this video, we're going to use the following rules of products and fractions to solve things like the square root of 12, the square root of 28, the square root of 72, and etc. We're going to start solving with square root of 28. Basically, what we want to achieve from the product rule over here is that we want two other products of square roots to be multiplied together. So we do that by finding one of those products to be, so we find the one of the products to be the square number, like 1, or not actually not 1, like 4, 9, 16, 25, 36, and so on. And the second one is going to be the number multiplied by this number to give us 28. So here the highest square number I can use is going to be 4. That multiplied by 7 is 28. Now what happens here is that if I have square root of 28 equal to 4 times 7 square rooted, I can separate those into square root of 4 and square root of 7, which gives 2 square root 7. So what happened here is that first I think of the highest square number I can use for the first, then multiply it by the number to get the 28. Then we split those products, because like here in the following expression, and what happens is that we find the square root of 4, which is 2, and square root of 7, which is a surd, so the surd is 2 root 7. Now the square root of 72. So what happens here is I need to find the largest product that is a square number and is then multiple of another to get 72. So here we could put 1, 4, 9, 16, 25, 36, 49, 64, 81. 81 will not be the case. 49 times 2 is going to be 98, so that's not the case. 64 is not also the case. 25 will give us 75 if we multiply by 3, and the only viable option is 36. So that will be 36, which is the square number multiplied by 2. And then we split those into 36 and 2 to get 6 square root 2. Now the square root of 50, we do 25 times 2, because the 25 is a square number, that is the highest we can multiply by, and we separate them into 25 and 2 to give us 5 root 2. Now for 12, this will be 4 times 3. So if we separate them, this will be 4 and 3, and this will be 2 root 3. Now we got root 20 over 2, which means that the top has to be simplified, and the top can be simplified by having the largest square number of 4 multiplied by 5 over 2, which is square root of 4 square root of 5 over 2, and the square root of 4 is 2, the square root of 5 is just 5, square root of 5, we cannot simplify further, and here we have 2, so 2's cancel and give us root 5. And now, to tackle this question, we need all of the roots to be the same to add them together. So basically, if we have root 6 plus root 6 plus root 6, this will give us 3 of root 6's. If we got 2 root 6 minus 3 root 6, this will be minus root 6. But if we got 2 root 6 plus 2 root 6 minus root 4, then the root 6 and root 4 are not friends, and what happens that those two are friends and this one is left alone. Now we need to find a way to get to root 6, and that's because this is the lowest we can go. So we can simply see from here that this square root can be 4 times 6, which will give us a square root of 6. So that will be 5 root 6 minus 2 and square root of 4 times 6. And here we have some number multiplied by 6. So again, we use this one first to assume that 294 is divisible by 6, and by doing the division, well, this is 49 times 6, and 49 is a square number, therefore it is correct, and we have 5 root 6 minus 2 square root of 4 square root of 6 plus square root of 49 square root of 6. Now if we toggle this together, 5 root 6 minus 2 multiplied by 2 root 6 plus 7 root 6 and 5 root 6 minus 4 root 6 plus 7 root 6 is the same as 5 minus 4 plus 7 of root 6's, and that would be 5 minus 4 is 1, 1 plus 7 is 8, so 8 root 6. This cannot be simplified any further, so it is 8 root 6. So what happens with this kind of questions is that we can use the lowest available surd to help us assume that the next ones could be the same of multiple of 6, like we did here, and to get them to 8 root 6. Now expanding brackets is really simple. We just do square root of 2 times 5 and square root of 2 times minus root 3. So square root of 2 times 5 is 5 square root 2, and square root of 2 minus square root of 3 is the same as square root of 2 times 3, which is minus root 6. Because we use this product rule. This will be 2 times 5 and 2 times root 3. And minus root 3 times 5 and minus root 3 times 3. Now, what happens here is that 2 times 5 is 10, 2 times root 3 is 2 root 3, minus root 3 times 5 is minus 5 root 3, and minus root 3 times root 3 is going to be the same as root 3 times 3, which is root 9, and root 9 is 3. So plus minus 3. And now we have discovered that if we have root a times root a, it equals to a. This is another useful thing to know, because in exam we can save time and effort by remembering this rule. So by having the two square roots the same, we get rid of the square root. And now we can collect the like terms, so 10 and 3 like each other, and 2 root 3 and 5 root 3 like each other. So 10 minus 3 is 7, and 2 minus 5 root 3's is going to be minus 3 root 3. Now we're going to look at some exercise questions. So we have 200 in a square root plus 18 in a square root and minus root 72 in a square root. What I can do is do the easiest one first. So this will be 9 times 2, and then 2 would be something that I would assume that we can add and subtract all together. So square root of 2 coming from that would mean that the square root of 2 could come out from the others, and it is somehow correct, because if we do 2 times 100 here, now we get 10 root 2, and if we do 36 times 2 here, we get 6 root 2 here. So we get 10 plus 3, which is 13, minus 6 is 7. So 7 root 2. And now the final one is where we expand the brackets. So 2 times 3 is 6, 2 times root 5 is plus 2 root 5, then 3 times minus root 2 is minus 3 root 2, and minus root 2 times 5 root 5 is going to be minus root 5 times 2, which is minus root 10. And we cannot simplify this any further, this any further, and this any further, therefore we leave it as it is. So I hope you have a good time of solving those questions for exercise 1D.